Here we go. Math 30-2, mid-chapter review. And today is Monday, November 19th. Here we have two exponential curves. What are our characteristics? First of all, we know that there's no x-intercepts. We know we have one y-intercept. They're either going to be decreasing or increasing curves that extend from quadrant 2 to quadrant 1. The domain is always x is going to be any real number, and the range y has to be greater than 0. Exponential curves have the equation y equals a times b to the power of x. A, as we've learned, is going to be our y-intercept. The b value, that is our multiplier, or our b value, as we call it. When we examine a table of values, x and y, notice that the x values go up, increasing by the same amount. 0, 1, 2, 3, 4, 5 in this case. And if the x increases by the same amount, the ratio of any term divided by the previous term in the y is going to determine our multiplier, which is, of course, our b value. Here we have 5, 15, 45, 135, etc. If we took term 2 and divided it by term 1, which would be 15 divided by 5, we would get the multiplier b value of 3. Before we do that, we want to say that the y-intercept has to be at 0, 5. So we know now that 15 divided by 5 is 3. We can look at putting an equation together for this. ab to the power of x. A is the y-intercept, which is at 5. B is our multiplier, which is going to be multiples of 3 to the power of x. Try that on your calculator and see how that works. Other important characteristics. Y equals a times b to the power of x. Well, we know that a has to be positive. A is greater than 0. We also say that b cannot equal 1. Now, if b is between 0 and 1, and we write that as b less than 1 but greater than 0, you will find that you have a decreasing function. That's what the first picture looks like. And if b is greater than 1, you are going to have an increasing function. For example, I want you to examine y equals 3 times 0.9 to the power of x and y equals 3 times 2 to the power of x. Compare them and draw a little picture. Lastly, what we learned was solving exponential equations. For example, 2 to the power of x plus 1 equals 64. If, and that's a big if, you can write the equations so that both bases are the same, you can set up an equation where the exponents must be equal. In our case, 2 to the power of x plus 1 equals 64 means that if I write 64 as 2 times 2 times 2 times 2 times 2, I'd write it as 2 to the power of 6 is 64. And 2 to the power of x plus 1 has to equal 2 to the power of 6. So now I've got an equation there where the exponents must be equal. X plus 1 equals 6. Taking away 1 from both sides, x equals 5. But, here's a big but, What if you have something like 3 to the power of x minus 2 is equal to 8? Well, now we cannot express the bases to be the same, so the only choice that we have open to us right now is to use our technology, which means our calculator. If you set y1 to equal the left side of your equation, 3 to the power of x minus 2, and you set y2 to equal 8, and you graphed them, you can find the intersection point. A little graph that shows this, we'll find one as being an exponential curve, the other being a flat line. The flat line is, of course, 8. And the point where they intersect, that's the x value, that's the answer. And the little arrow goes down to show you that's your intersection point. Try it. Your assignment is page 368, numbers 1 to 10, and that'll be a handy assignment.